Assalamu alaikum our students in grade 12 and Ramadan Kareem. I hope you are enjoying Ramadan at home. Okay, we need to continue in our lessons in Unit 5, Atomic Physics, and today we will take the fourth lesson, which is talking about the hydrogen spectrum. The hydrogen spectrum. And in this lesson, inshallah, we will see how the scientists study the hydrogen atom and study also the spectrum emitted or absorbed by the hydrogen atom. And actually they choose the hydrogen atom because it's the simplest atom. It has only one electron and one proton in the nucleus, as shown in this picture here. So let's start. The first question we have here is, what is the hydrogen spectrum? What we mean by hydrogen spectrum? Actually, in last lesson we explained the spectrum in general, and we saw what does it mean exactly. But today we are asking about the hydrogen spectrum. The answer is, it is a line spectrum. A line spectrum, as we said before, a spectrum divided into continuous spectrum and line spectrum. So the hydrogen atom, as any chemical element, gives what? Line spectrum. Emission or absorption. Contains a limited number of wavelengths in a regular pattern. These lines are classified in groups called spectral series. Spectral series. That means we will study, inshallah, the line spectrum emitted or absorbed by the hydrogen atom, and we will see that the spectrum can be found as series. Series, it means collection of lines together having the same name. And actually we will study 5 series. All of them belong to what? To the hydrogen atom. So first we have some notes here. The first note explaining these lines, spectral series. The difference in wavelengths for these lines is rapidly decreasing in the direction of shorter wavelengths. That means when we go to the side of shorter wavelengths, or when the wavelengths becomes shorter, the difference between the lines in the series decreases. And this is the first note. The second note, in 1885, a Swiss school teacher, his name is Balmer, found an empirical equation. Empirical equation, it means experimental equation. That means after many experiments he gave us an equation that correctly predicted the wavelengths of 4 visible lines of hydrogen. That means he gave equation. By using this equation we can calculate the wavelengths of 4 visible lines, and later on actually these lines took the name of the scientist Balmer. Then they call it Balmer series. Balmer series. Which equation exactly? This is the equation. The equation is 1 over lambda equal RH, and we have brackets here, multiply by 1 over 2 square minus 1 over n square. So what we mean by RH here, RH is Rydberg constant, and Rydberg was also one of the scientists who was working with Balmer, and after they finish this equation, they gave him, or they gave the constant RH his name. So RH is a constant having this value appear in front of you here, 109,677.58, and the unit is centimeter minus 1. And this n here, it's a variable. Start by 3, 4, 5, and so on till infinity. That means the first number of n is 3, then 4, 5 to infinity. And 1 over lambda, we call it wave number. And lambda, as you know, it's the wavelength. So in general, this rule used to find or to calculate the wavelength of each line belong to what? To Balmer series. And as we said, we have 4 visible lines. Okay, now let's see how these lines looks. If we put the excited hydrogen atom as a sample here, if we put it in the spectroscope as we studied before, so it will be like this. This is the excited hydrogen atom, gives radiation. The radiation passed through the slit and passing through the prism. The prism will analyze it, and in the detector we will get what? These colors. The colors will appear as lines, like we can see here. This is the first line, red. This is the second line, then the third, then the fourth. Then the lines gets closer to each others till they become, or they appear like one line. And actually this one is called hydrogen emission spectrum. The bright lines in the spectrum are the wavelengths emitted by the excited sample of hydrogen, those colored lines. In the other side, the same idea, but now we use white light to excite the hydrogen atom. So we put the hydrogen sample between the white light and the slit. That means here the hydrogen atom will absorb a part of this white light, and then the light also will be analyzed by the prism, and it will give us this picture. So we have here black lines. Black lines, it means a part of this color is completely absorbed by the hydrogen atom. That's why it becomes what? Black. But we can see the black lines are in the same position like the colored lines. And in this case, we have hydrogen absorption spectrum. The missing wavelengths in the above figure are absorbed by the hydrogen sample. And I think if you compare between the two pictures, you will understand the differences between them. Here we have line emission, and here we have line absorption. Okay, now let us continue in our notes. Now in this note number 3, we have explanation for the value of n. The value of n, when n equal 3, we get the first spectral line, which is called H alpha. I mean by n equal 3, that means according to the equation, Balmer equation, we explained it before. So if you put n equal 3, this means you will get the first spectral line. When n equal 4, we get the second spectral line, and this time we can call it H beta. So H here for hydrogen, and alpha, beta, gamma, this is just counting, and so on for the other spectral lines. That means we can continue in the same way, increasing the value of n by 1 to get 5 and 6 and 7 and so on, and then you can get what? More spectral lines in Balmer series. In note number 4, the spectral lines become closer to each other as n increases, till they combine as one line when n equal infinity. That means if we increase the value of n step by step, the lines of Balmer series become closer to each other till infinity. When n equal infinity, here all the lines combine together to form one line. So they are going to become closer to each other step by step till n equal infinity. And actually you can see this so clear in the picture we explained it before. Okay, now let's take examples to apply this Balmer equation. And in this example here, using Balmer equation, find the wavelengths of the first and the second lines. They mean the first and the second lines in Balmer series. So for the first line, n equal 3. This is the first value for n. So let's put the rule and then substitute n equal 3. This is the rule, including RH, Rydberg constant, multiplied by this bracket. So you can see here n is variable, which is here equal 3 for the first line. So we will substitute the value of Rydberg constant and then n equal 3. By using the calculator you will get this answer, but this answer not for the wavelength. This is the wave number. The wave number. If we want the wavelength, we will flip this answer to get the wavelength, and the wavelength here equal 6.564 times 10 to the power of negative 5 centimeter. We can change it into angstrom by multiplying this by 10 to the power of 8 to get this answer. So now this is the wavelength of what? The first line in Balmer series. For the second line, n equal 4. Now n increase to become what? 4. Same way we will substitute it in the equation. RH is a constant, never change, but now n equal 4. We will get this number as wave number for the second line. To get the wavelength, also we can flip this number and here is the answer of the wavelength. In centimeter first, then multiply it by 10 to the power of 8, we can change it into angstrom. So this is the final answer for the wavelength of the second line in Balmer series. I hope that these examples are understood, but if you have any questions, you can ask me directly. Now it's the time for the homework. In this homework, find the wavelengths of the third and the fourth lines in Balmer series. You can see here in the example, I found the wavelengths of first and second lines. I want you to continue in the homework same way and to calculate the wavelengths of the third and the fourth lines in Balmer series. So try to do your best to solve this homework. If you have any problems, you can ask me directly, and inshallah he will get the answers for your questions. Okay, this is the lesson of today, and we will continue in our lessons till we finish this unit, inshallah.